All right, Doug, now it's time to look at some of the high altitude performance difference of the 737. We're at thick air at 15,000 feet. Now we're up here at flight level 350.
Okay.
We want to make this realistic, so it's still a fairly heavy 737-800. We just leveled off. If you go to your cruise page there, what's our optimum cruise that shows right there in the FMC?
35,000 feet.
And that's what we're flying. So this is a realistic scenario. Your maximum available flight altitude in the FMC?
Shows 37,200 feet.
There you go. And if we look up here on our cruise N1, just to maintain Mach 7.9, which is our FMC speed, econ speed, what's our N1 values right here to maintain this speed?
We're just a little bit below there, the cruise setting, so it's about 93.5.
Yeah, and so at 15,000 feet, our N1s for the same weight, we're about 77%. So we're using a lot more thrust here at altitude. And if we look over at our speed limit, what type of limits do we have on our speed tape here?
Well, you can see that the envelope is definitely a lot smaller than it was down there at 15,000 feet with these giving weights.
Beautiful. So up here above 26,000 feet, it's VMO, our maximum speed, Mach 0.82. And we can see down the min maneuver speed down here with the buffet tape. So a lot less thrust available. In fact, at 35,000 feet, we only have about 10% of the available thrust that we had at sea level. So much more limited there. So this first thing we're going to do is we're going to have you feel some of the dynamic instabilities of the thin air here. The lack of aerodynamic dampening means that the flight handling characteristics are going to be much more marked to you. Okay. For the same pitch excursion that you put in on the yoke, you're going to get about twice the effect. It's going to just feel a lot less thick air, so it's going to handle differently. Now again, just as demonstration, the yaw damper is turned off so you can feel some of those instabilities.
Okay.
So when you're ready, we'll go ahead and have you turn off the autopilot and the auto throttles. Just get the feel of the jet here, and your angle of attack is pretty much the same at 15,000 feet, about 2.3, 2.4 degrees. And we're going to show some of the deceleration characteristics here too. So now go ahead and reduce the thrust back to idle and maintain flight level 350.
Yeah, I can tell already that it's a lot more slippery here at altitude.
There you go. And now in a little bit, we're going to have to go max continuous thrust. I'm going to line select that. That's up to 101% N1. I'll set our thrust caret up here because that's what we're going to need. So here's our deceleration rate, typical to what we had at 15,000 feet.
Right.
It's decelerating. Now what we're going to get here, Doug, is the lack of thrust available that we had at 15,000 feet. Now we're at 240 knots. I want you to go ahead and select max continuous thrust here.
Okay.
And it can take up to 40 to 45 seconds to fully accelerate the engines at altitude here. Much longer to spool the engines up to maintain the thrust.
That's real noticeable.
So now we're up to max continuous, about 101%. Put it right on up there. And what's happened to our acceleration rate right here?
We're accelerating, but it's not by much.
Yep, it's just very stagnant.
Yeah.
So the idea at high altitude, if you see any deceleration trends, you want to catch that very early because you might not have the additional thrust to accelerate back to your required speed.
So let's say that I'm headed out of Seattle, headed back east, level off, headed out over the Rockies, and I hear somebody up ahead of me, and they're talking about some mountain wave. Would it be a good idea to reach down there and just select continuous maybe?
Yeah, absolutely. Normally, when you level off, the cruise carets and the thrust mode enunciator will just go to cruise. You can see the cruise value is 96.8.
Right.
Where that max continuous, it gives you 101%, gives you additional thrust. So if you're expecting mountain wave, turbulence, or conditions that you want that additional thrust capability, you can line select that, and that'll allow the auto throttles to go all the way up to max continuous.
Right.
So again, if we look over here, we're barely accelerating at all. In fact, we're really close to the backside of the power curve.
We are, yeah.
What's your approximate angle of attack here?
I've got 4 degrees.
4 degrees, and it's not a whole lot more. 4 degrees at 15,000 feet, the aircraft can easily accelerate. But here, that lack of additional thrust and that increased drag that's related to the increased angle of attack is not allowing us to accelerate very efficiently here.